right, let's do some applications of similar triangles. Remember, similar triangles have the same three angles. Okay, this is kind of a tricky one here because we're asked to find the missing side length x. Now we have to assume this should have a right angle in here. So we have to assume those are right angles. And something to remember when we were talking about vertical angles or x angles, we said that this angle here would be the same as this angle here. So those two angles are equal. We've got that angle, so our blue angle plus our 90-degree angle there. And so that third angle must be 180 degrees minus those two. So I'm just going to write that like that. That means the same thing over here. So we do have similar triangles here. They have the same three angles. Now, when you're trying to set up your ratios, it looks a little funny in this orientation. So one thing you can do is kind of think about grabbing onto that second triangle and rotating it if it's helpful to you, or you don't have to do this step. But I'm going to rotate it around so that now my 78 centimeters is over here and my 92 is over here. And I just do that so that it's really easy to match that to the other triangle there. I can see clearly now what my corresponding sides are. Okay, now we have to set up a ratio. We're trying to solve for x. So I'm going to say x over 98. And so that equals, looking at that triangle I just set up, that would be the same. The corresponding side to x would be the 92. And the corresponding side to the 98 would be the 78. Okay, I guess I don't really need to think about my centimeters yet, so I didn't need to write centimeters in there. Let's multiply everything by 98. In other words, we're going to cross multiply that 98 up and over the equal sign. And that's going to give us, so those cancel, x is, now I really need my calculator. There it is. Okay. So x is 92 times 98 equals, divided by 78 equals, and we're told to round to the nearest tenth. So I've got 115.589 and so on. So to the nearest tenth, that would be 115.6, and we're in centimeters. Okay. This next question here is also a similar triangle. So here we have to assume this is 90 degrees. Sorry about that. We'll assume that is 90 degrees. We have a larger triangle, and then we've got a smaller triangle enclosed within it. So if we think about this angle is obviously the same between the two triangles because it's in both of them. That means that our third angle here must also be equal because it's 180 minus the green minus the blue. 180 minus the green minus the blue. So those two are also the same. Now I'm going to take that small one. You don't have to do this again, but I'm just going to draw it over here to show you that this is really just a case of similar triangles. Oops. Okay. And so the smaller triangle, we have 32 centimeters and 14 centimeters here. Okay, and we're looking for angle x. So using your similar proportions, see if you can solve for, sorry, I said angle, for side length x. Okay, so hopefully you had a chance to pause this video and try this one on your own. One trick part of this, or one, extra challenging part of this, is that this side length, we don't know, but we know that it's going to equal the sum of 13 and 32. So this side length here is going to be 45 centimeters. So then when we set up our ratio, we could say x over 45 is going to equal, so now we want to look at the corresponding sides, that would be 14 over 32. And so now we can multiply both sides by 45. And we're going to have, so that these cancel and we're left with just x. So x is 14 times 45 equals, divided by 32 equals, and so I get 19.6875. So to the nearest tenth then, I would have 19.7, and this is in centimeters.